Functions are like any other M files, such as the script M file, but they accept arguments and produce one or more outputs. Function stores variables in a workspace that are shared internal to the functions, so it does not have impact on the workspace variables, or the workspace variable won't have impact on the function variables. It is always recommended to name function file for the same as the function name, and you're going to see this in the MATLAB demonstration for function building. So this simple function shows the basic parts of an M file. Always in the first line of your function M file, there are 4 elements. First, you need to type function, which is to declare that you are going to build a function M file. And then F, which is the output, equals the function name and input. And in this example, the first line is function f equals factorial of n. So from the name you can see this is about calculating the factorial of n. And there are 4 lines in this example, 1, 2, 3, 4. And in fact, 2 and 3 are just comments. They don't execute at all. So the key lines are the first one and the last one. The first line is the function definition line. It defines the function name, the number, and the order of input and output arguments. And the fourth line is the function body, which includes codes that carry out the actual computing. So in this simple example, there is only 1 line needed for the computing. So the function body is only line 4. As mentioned just now, the structure of the function is the first line is to declare the function and define the function by function name and the inputs and outputs. And then the function body are the command lines to execute the calculations required for this specific function. Now we start with example 1, which is to calculate the total impedance of the RLC circuit, which is Z equals R plus J times omega L minus 1 over omega C. And for details or principles of this example, you can look at it in the textbook. Here we just focus on the solution of Z using a function. So here is the code we use for defining the function and execute the code to compute the impedance. So here, as mentioned, the first line is definition of the function. Function x equals impedance example. Inputs are RC and LW. So here, the output x is in fact a vector, which contains x1, x2, x3, and x4. And the requirement for this example problem is to return XL, XC, XL, and magnitude of Z and magnitude of and the angle of Z. So these 4 elements will be saved in the X vector. So look at the function body. We can see that x1 can be solved by 1 over W times C. x2 is W times 1. And here W is in fact omega. And Z2 equals R plus 1i times x2 minus x1. So this is the main function for solving Z. And x3 is the absolute of zt, which gives us the magnitude, and x4 is the angle of zt, which gives us the angle of z. And in the end, if we call function impedance example in our command window by inputting x equals impedance example with the given numbers for RC, L, W, we can get the output x with 4 elements. And example 2 is to model the vibrations, and the equation for this motion problem is yn equals 2 times a times yn minus 1 minus b times yn minus 2. Again, you can see the principles of solving this problem in the textbook. And the following function, mfile, vibration modeling.m, is the function for modeling the vibration. Again, the first line of such an mfile is to define the function itself. Function bracket y equals vibration modeling of inputs a, b, and number of points. This function is to calculate the mechanical vibration based on vibration model that is given on top of this slide. And here you see a for loop, which we will introduce in the last session of this lecture. And after we define that function, we can use a script file to call this function and to display it by using the plot function. And here the script, we save it as plot vibration.m. So in this m file, what you're going to input is first we give the values for a and b and number of points, and then we start a new figure by inputting figure semicolon. And then here, what you need to pay attention is this plot line. So here we call the function that we defined, which is the vibration modeling from the previous slide, with the given a, b, and number of points. This is called passing the values to the function. Pay attention that we pass values twice. First, we pass a, b, and number of points into the function vibration modeling, which we just defined. And then the output of the vibration modeling is passed to plot, to be used for plotting. And there's a special type of functions in MATLAB, which is called anonymous functions. Anonymous functions define simple user-defined functions without developing a full-blown M file. So recall the first example in this function section, which is to calculate the factorial. There is only one line code in the function body to execute the calculation of the factorial. And similarly, there are many other functions that can be executed with one line. In that case, we can use anonymous functions. So instead of using two lines, first line to define function output equals function name of input list, and with expression, which is the function body, we use one line, which is fhandle equals at input list expression. So we will show this in an example, which is f1 equals at fxy at x squared plus y squared. So this is just to calculate the sum of square of input x and y. Once these functions are defined in the command window, they can be used just as other functions. We just call f1 with input. Here, input x is 3 and input y is 4. And we